it was a quite muddy road at times, so I thought I should share some of the pitfalls that we ran into, that you probably will run into as well if you're trying out mode programming. So one of the first things that we encountered, and you might encounter as well, is that it feels like you're in the middle of a hen house. Everybody is talking all the time at the same time over each other, and I know somebody needs to brag about they know the domain logic the best or the business rules, and yeah, all these kind of heated discussions. In our case, it was a lot of hot debates about how to perform a certain refactoring in IntelliJ with the least amount of keystrokes. So it can be productive, but that's really what we're there to do, to solve the problem we're working on. So when we start to think about this, think about flow, and have a sense of progress on the problem we're actually trying to solve, things will get better. Like, maybe we don't need to have this discussion now. Is it contributing to solving the actual problem? Maybe you can bite your tongue for 15 more minutes about that urgent need for refactoring you notice in the source code that nobody else of your teammates seems to notice. And if you work with the test-driven development, for instance, and use the red-green refactor approach, which means that first you write a test that fails, goes red, then you implement the code to satisfy the test, so it goes green. Then you can refactor the code, and then you can have the opportunity to tune the implementation, and you don't need to have these crazy discussions all the time. So keep focus on the problem you're actually trying to solve. Keep that in mind all the time. And a good thing in mode programming, since there are more people sitting together, there's always somebody to remind you about, hey, let's take a time out here. This is not really what we're trying to do here. In the beginning, we noticed we had a lot of discussions about coding standards. How do we want to structure a source code, how to name things, and so on. And to be honest, as developers, we tend to read more code than we write. So it's always good if the code looks coherent and consistent throughout the code base. We've probably all seen code bases where we can definitely see that this method over here was probably written by John because he always has a particular way to name his methods or variables, and Mike probably wrote this because he's more sloppy with indentation or whatever. But as we went along, we could agree upon coding standards, and after a while, all the code looked the same, regardless of who wrote it. And I mean, there could be some things that maybe I didn't like personally about the convention, but we agreed upon it, and that's how we went forward. Which brought an interesting aspect as well. When sometimes you want to look in the source code history for who introduced a particular change, you might not even be certain that the person's name in the commit log was actually a person at the keyboard at the time. So we thought, okay, how can we make sure that we always address this issue and we can have the full traceability of who were actually involved in a certain code change, since we can't really trust the author. That's just like the author of the machine we used when mode programming. So we solved this in a quite simple way. We just made a convention that on the second line of each commit message, we just specify all the team members that were involved in a code change at that particular time. And we had a git commit hook upstream in our source control system to actually verify that something was specified on the second line, and these names that were specified had to match the names of the team members at that point in time. So we could always have full traceability of who were involved in a certain code change. But to be fair, most of the times it was everybody. Another problem you might face, which is not really unique to mode programming, I've encountered it when I'm pair programmed as well, and it's one person starting to hog the keyboard and sits for a very long time. It gets boring to sit on the side, and it's hard to keep engagement up. So we solved this by just simply adding a timer. We tried with physical timers, but we ended up with one in our IDE, which you could set on a fixed amount of time, for instance 6 minutes. And when the clock went off, the person at the keyboard just raised its hands and passed along the keyboard to the next person. And this way we could make sure that everybody was constantly contributing, because we were all developers, we all love to code and sit at the keyboard. But also we could keep engagement up and fight boredom. And this worked well. It was a good first step, but since we sat like from early morning until lunch this way, and same in the afternoon for very long periods of time, people have needs. Somebody needs to get a new cup of coffee, or get a banana, or use a toilet, or somebody starts checking their phone after a while, and all of a sudden you're there at the keyboard, you start to notice like, I'm just surrounded by a bunch of zombies looking at their phones, and this is not really contributing to the actual solving the problem. I'm creating these new features. This is not mode programming. This is just, I guess, zombie programming. So, okay, we thought about this. How can we keep engagement up? So we want to fight the boredom, but we want to stay focused. And it's exhausting, so maybe it's good to have some breaks. So we start to employ the Pomodoro Technique. So if you haven't heard about the Pomodoro Technique, it's essentially about you sitting focused for a certain period of time, for instance, 25 minutes, working on completing a certain specific task. And after that period of time, you take a few minutes break, get your mind off that and think about something else. You can get a coffee or something. And then when you start again, you can work focused on solving either the same task if you didn't complete it, or a new task if you solved the previous one. So this worked quite well for us. We noticed that when we took a break, people could go and get their coffee or bananas, make the phone call they need to do. But when we all gathered back after a few minutes of break, we could work focused, because we knew now we need to work focused for 25, 30 minutes, and then we'd have the next break. So it made it so much better in terms of keeping the engagement up and working focused and actually solving the problems we were supposed to solve. And to remind us of all these concepts that we agreed upon, the ways of working, we just decided let's create a simple checklist to remind us of these things, because we're humans. We're quite horrible at remembering things we've agreed upon. So we just created a checklist, printed it, put it on the wall next to our TV screen, so we'd always be reminded until we had this, like in the back of our heads naturally, we didn't need to think about it anymore. So one thing when working together quite closely is to make sure that everybody's comfortable. And one of the things we had was we had a debate on which kind of operating system to use. We had like a 50-50 split between developers using a Mac, like myself, or the others that use a Linux. And we noticed it was quite cumbersome for the people not used to a Mac to use a Mac when we used a Mac. And we had different key maps in IntelliJ, which was hard, even though we were familiar with the keyboard layout. So we decided everybody's familiar with or comfortable using a Linux computer with like the standard key map of IntelliJ. Let's use the same aliases in the terminal, so we can all be comfortable working in this environment regardless of which box it is. This is the Linux box, and everybody feels comfortable being the driver, and we can be productive. We also remind ourselves about the things that I mentioned, like let's set a timer, remember to take the breaks, have discipline, and most importantly is to have fun working together. But when we worked with this for quite a while, we had all these different things that were on the checklist in the back of our heads, which started to be comfortable. We discovered that we didn't really need the timer as much, because we discovered this concept called strong pairing, which is something you can use when you pair program as well. We noticed that at times when we had some idea, somebody knew how to solve a particular problem, they took the keyboard, started hacking away, and all of a sudden all the other people around that person just tried to decipher the code that was written on the screen, or if there were a lot of window juggling, you almost get seasick, what's happening, hard to follow. So we thought, like, okay, but maybe it's better if the person who has the idea does not have the keyboard. And this is essentially what strong pairing is about. That you have a driver, which is the person at the keyboard, and you have a navigator or multiple navigators that are the ones who have the idea and can talk in a high-level abstraction on what problem you're trying to solve. So, for instance, you can think about this as having a driver and navigator in a car. So, if you have a driver and you have a navigator, and we want to get from here to Amsterdam, for instance, as a navigator, you talk in high-level abstraction. You don't need to tell the driver to, all right, now press the clutch down, shift up, release the clutch while pressing the throttle, take the left lane, overtake the Fiat, and so on. We can trust the driver to know all these details, otherwise we wouldn't put him in the driver's seat in the first place anyway. And the same thing when we code. I mean, we all know that everybody can code Java in our team, so we can trust that person on that level. We can talk about the ideas, how to solve a particular problem. And this was it felt very natural, and we didn't need to work with a timer as much anymore, because now it was natural, like the person had the idea, just dropped the keyboard, or many times we gave the keyboard to the person that was most confused about what we're trying to do, actually. So, or sometimes I came from a meeting and joined the mob and was like, okay, where are we at the moment? What problem are we trying to solve? And so on. And I just got the keyboard and like, okay, this is it. We're doing this API endpoint right now. It's supposed to take these parameters. We want to handle this in this way. Okay, I can start fiddling around with this. And quite quickly, you're into the loop of what we're trying to solve. During 1 week, we had a few production incidents, which made me, as a coach for the team, to focus on quality on the next retrospective. And one of the outcomes from that retrospective was that we should probably do more strict TDD. I mean, we had automated test cases for everything, unit tests, component tests, integration tests, but we didn't really always write the test first. It was mostly written afterwards. But I thought, okay, let's give it a chance and write the test first all the time. And we noticed a quite interesting side effect. Not only did the code quality go up, but also we noticed that we didn't need to do a lot of rework on some things that we didn't really have the same understanding of. So before we started implementing something, we wrote the test cases, and already there we could notice that maybe there's a corner case here we didn't think about. We just set the expectations for everybody in the team on how to solve a particular problem, which is quite useful. So this is how it looked like when we started with mode programming. We just had the TV there, a big sofa. It was all right in the beginning. It was quite shielded off. But to be honest, sitting 8 hours in a lousy couch isn't that ideal. I mean, nobody's getting younger. We got back pains, and not everybody even fit in the sofa at the same time, which we're Swedes. We don't really like to be that intimate with each other. So we decided to upgrade our team area and bring in a proper table so people could bring in their own chairs there and have a comfortable environment. And also on the screens on top, you can see that we have our continuous delivery pipelines and our live monitoring from the production systems, always visible, so we could have fast feedback on the things we were working on. So we were sitting there the whole days, every work day, and we looked at, when we're coding, like, is this a small change that we can do, an isolated change that we can just send out to production? Then we shipped it, and we can just follow in the continuous delivery pipelines on the screen, how we went through the pipeline, if it passed all the gatekeeping. If something went red in the pipeline, we could immediately address that while we're still in the same context of that problem. Or if there was something happening in production, we could get fast feedback and address that right away. So I thought I should talk a little bit about continuous delivery, which was something that we used. It's not a prerequisite for mode programming in a sense, but it worked very well together. So when we talk about continuous delivery, it's about getting code changes out to the users as quickly as possible in a safe, reliable, repetitive way. So there are two requirements for you to fulfill in order to do continuous delivery. The first thing is that your source code should always be working. It should always be in a releasable state. And the second thing is that the whole delivery process should be fully automated. So in our case, we use continuous deployment. So every time we push code, we could just follow it through the pipelines on the screen, and 25 to 30 minutes later, it was out in production. Had the benefits that we always knew what was in production. We never need to think about, is this live or not? When does your code bring value to your users? Well, it's when it's production, and it's the end of the main branch if you're doing continuous delivery. So we use trunk-based delivery all the way. We never use branches, except for if somebody had to safe keep something that we didn't push production before we went home. So we want to keep doing that the next day or something, unless we have a hardware problem or something. But always use the master branch. Because if you're doing branches, you're not really integrating your code. That's not continuous integration. Then you can't be sure that your software always is working. And to be honest, if you're doing mob programming, everybody's working on the same thing anyway, so there's like really no point in doing branches in the first place. A lot of people use branches and like pull requests in order to do code reviews. But if you're doing small incremental changes all the time, that will just add a lot of waste and extra time for people to go through and read. And if you start stacking up smaller changes on top of each other, it's going to be hard to keep up. And if you have bigger diffs, it sometimes can be hard to like really digest what's the intent of the code change. And something that you don't really see in a diff is also what solutions were discarded before opting to this particular solution. Sometimes it's easy to look at a pull request and think about, why didn't the person solve this in this way? But maybe they already tried that, but it had some other implementations that you can't really see in the diff, and that solution was discarded. And you have all this wasted time going back and forth, discussing the diff, instead of just doing the code review immediately together, talk with each other, communicate, and you can be much more efficient. So in our case, we just prefer to always do the code reviews pre-push instead of having a separate workflow, so we can use the trunk-based development approach all the way. So some of the benefits that we saw when we were using mob programming, it was like a bulldozer. The mob was always going on, full steam ahead. It didn't really matter who were at the office. Somebody was sick or somebody was on vacation. Everybody was always on top of things, knowing what was going on. If we ran into an impediment, somebody needs to go talk to another team that we integrated with. We could just take that person, go talk to the other team, and the mob could just go on. Or if somebody came to us with a question, one person could pop up and answer this question, where the mob would always continue working. But only because you're used to using essentially one computer, it doesn't mean that you can't work in parallel. So one quite useful concept that we noticed was, let me give you an example. If you're coding something, and you will notice that eventually, in like 15 minutes' time, you probably need to interact with the database, and we need to design a new database query to pull up this data. Then one person, preferably the SQL guru in the team, can just pop up his laptop, start developing that SQL query, while the mob is continuing with a Java code. And once they get to the point that they need to actually implement the SQL query, it's already solved. So it's quite useful to work in parallel, or if you're running into a problem, you don't really know which Spring Boot annotation to use, and somebody can work on a separate computer to read in Stack Overflow how to solve that problem, while the mob can continue with something else. So it's working in parallel, but at the same problem at the same time. So one of the biggest benefits with mob programming is obviously that we can make use of all the collective skills that we have in our team to solve our problems. So let me illustrate that with an example. For instance, if we have 4 identified skills that are core to our team in order to be efficient developers, in our case, it could be like Java. You need to know how to code Java to be efficient. You need to know TDD to some extent. Run your stuff on AWS. You need to know AWS in some extent. It's good to have some operational skills, setting up host-centric, application-centric metrics, feature switches, circuit breakers, this kind of stuff, since we are responsible for operating the stuff that we develop. So if we have one person working on a particular problem, he might be very good with Java, so-so on TDD, has worked with AWS for many years, but hasn't really the ops background. So this is a person who could be fairly comfortable and effective in the team, but still lacks some important aspects, because if we're supposed to deliver all the code changes automatically into production in 25-30 minutes, you need to really think about how you structure your code in order to not break stuff in production. It's quite interesting. It's like when you start with doing TDD, you're going to notice that your source code is going to look more differently. You're going to structure it so it's testable. And the same thing with when you're doing continuous delivery or continuous deployment, you're going to start thinking about when you develop, how is this going to be operable in production? Do I need to take into account back pressure, circuit breakers? What metrics do we want to have monitoring in order to notice if something blows up in production? So, but if this person would pair program with somebody that has the ops skills, it might look something like this. They could be more effective and productive, and maybe avoid some of the pitfalls or problems that they could run into otherwise. But there's still some gaps here. We could probably be better with test-driven development, or making sure that we cover all the necessary corner cases we want to cover in our test suites. But then if we add a third person, who might be a Java and TDD expert, we've all of a sudden addressed all these different aspects, and we raised the overall skill level of the team to take into account all these different aspects that we need to think of when solving problems together. So we just make use of all the necessary brain power in our team in order to deliver more efficiently. Another benefit was that basically anyone in the team could represent us in a meeting. We didn't need to go everybody, or the most senior one or the team lead needs to show up on all the meetings and never be participating in the coding. So we could just rotate, like, we want to take this meeting, oh, I can go today, or you can take it, I'll go to the next one, or something like this. In fact, most meetings were eliminated, since we could have discussions or decisions made as we went along when they occurred in the team. And we didn't need to book a separate session, like, let's design this or agree upon a standard. Let's do it next week on Tuesday. We have to find a room first. Okay, it might be Thursday because there was no rooms available. And knowledge sharing just happens all the time. It's just a natural thing. We even had some persons that left the team to go to another team in the company, and we basically needed no handover because everybody already knew everything that was going on. So it was a bit strange feeling when somebody left the team, like, okay, I'm not going to be in the stand-up tomorrow because, yeah, I'm joining the other team, but do you need anything from me? No, yeah, have fun. Okay, let's see you later. Let's have lunch someday. And our product owner, he was super happy. As developers, we might not think about it from a product owner's perspective that often, but the product owner, he's really interested in that the most prioritized thing, the most important thing, gets delivered as quickly as possible. A product owner is not interested in having 5 things being worked on at the same time, moved a little bit on the Kanban board every day for a few weeks' time until they're delivered. Because in a fast-paced environment, priorities change almost on a daily basis. So the thing that's the third most important thing today might not even be interesting in starting implementing tomorrow. Or there might come some new important thing that the product group has decided upon building that needs to go on top of the backlog as soon as the most important thing right now has been solved. So it made it much more flexible in terms of priorities and like agile in that sense, that it's more agile in what we can focus on, working on. And we have decided that keeping all the tickets that we work on fairly small, like it should take 3 days to implement each one of them. If it takes more than 3 days, it's probably too big. So we had, on the daily stand-up meetings every morning, we put a dot on each tick that we worked on. And on the third day, when there was 3 dots, we decided, okay, we need to finish this today. Are we confident that we will do that? If yes, then we'll finish it. If not, then let's just slice it and see what user value have we already provided or can we provide. So maybe we can provide 80% of the user value today, and leave the rest of 20% separately. So we can just create a new ticket for that, reprioritize that, and maybe we can do some more important stuff before we add this last 20%. So I get a common question I get is what's the team size you should have for mob programming? How many people is sufficient? Is it 3, 5, 7, 1,000 or something? In our case, in our team, we were mostly between 5 and 7 developers during my time there. And for us, the sweet spot was probably 5. At 7, we felt it was a little bit too much, but when we were 7, then we usually had like a pair programming and a mob with the rest of the people. And we decided on the daily stand-up meeting in the morning which formation to use for which particular problems. But to be honest, if there's 7 people, there's probably always somebody going to be sick or on holiday or with sick kids. So we mostly just mobbed, and we did that every day. We just never worked solo at all. One other important aspect, I think, was when we realized that we should have some kind of definition of when it's okay to start working on a particular issue. I mean, in the Agile movement, it's so common that when you start a new team, you have to decide on, we have to have a definition of done to know when we're done. And still, when we're working on stuff, we end up in these discussions about, okay, but this feature, is it done, or is it done, or is it done? And nobody knows. But for us, we really noticed a great effect when we decided that before we can actually start working on a particular issue, it has to fulfill a certain set of requirements. For instance, everybody in the team should understand the problem, because if you can't describe the problem, you will never find a solution to that problem. And you should not be blocked by external dependencies. So if we were integrating with another team and they were not ready, we needed to have some data from them in order to start, we would simply not just start working on that, because we don't want to work halfway, get blocked, and have to wait. Everybody should have a common understanding, and the ticket should not be too big. So we had these weekly refinement meetings when we went through the top of the backlog to make sure they were ready to be started working on. Because the real cost in software development isn't writing lines of code. The real cost in software development lies in actually solving the problem. It's all these wasteful tasks, waiting and so on, and then it's rework. And we hate rework. It's demoralizing and boring, and if we can avoid that, we can get a much more better sense of progress and productivity. So with these concepts that I've talked about today, we were able to go from 12 tickets a month to 50 without changing the ticket size, compared to when we worked solo or pair programming as we did before. And also we look at the amount of the production deployments we were able to muster every week. The average in the company across all these teams were around 5 to 6 production deployments every day. For us it was between 20 and 25, like the normal pace. But some days we were able to even go up to 60 production deployments every day. So we really outpaced other teams in terms of productivity and pace. And another important aspect, I think, is to actually work as a team. It really felt for us that we were working as a team together, prestigeless, and with a common goal. Because we talk a lot about development teams in our industry, but is it really a team that has the same goal, or is it just a group of people sharing the same interest? You can compare it to an ice hockey team, which has the same goals, to win the game or the championship, or just a group of people playing pickup hockey on a frozen lake. They're probably there for different reasons, but they have a common interest. But the important aspect, I think, for you to get this to work is to make sure everybody's comfortable, we work together as a team, no prestige, and have a lot of fun while doing it. Thank you very much for listening. So we have some time for questions. I think we have a mic over here. Can you use, right? or just shout and I can repeat the question.
Yeah, I have a question.
Yeah, please.
Was it possible for someone to work at home if there was a situation at home?
Yeah, so the question is, was it possible for somebody to work at home? We didn't really involve those people in the mob. We didn't really have the proper programs or infrastructure for that, I think. But in most cases, we just found something maybe isolated those persons could work on, and they usually joined us on Hangout for the stand-ups and so on. But usually, when somebody worked alone, it was still the most inefficient thing. But I know there are teams that are more successfully tried out with the remoting thing, with screen sharing tools and so on. But we didn't really try that in that sense. Yeah?
Did you only have developers in the mob or also testers, analysts?
So the question is what roles basically we had in our team as developers. Well, since we had teams with had end-to-end responsibility, we need to cover all these different aspects. So we all had different like specialities in the team. Like, for instance, I'm more into test automation than maybe the others. So maybe I thought more about how we're going to test this, what kind of test cases do we need to write. But we had everything is automated, like all the tests. We didn't have any like, oh, this is a test person, I do manual regression tests, because that's kind of becomes a bottleneck and counterfeits the continuous delivery approach. But we have some people more skilled into the operation things, AWS, while more people were skilled in the core Java things or new Spring framework which we used. So we had a lot of different skills, but I think it's a lot about how you assemble the teams as well to make sure you have this good mix and address all the different aspects you need to consider in order for a team to be effective.
Were there people that didn't like mob programming?
Yeah, were there people that didn't like mob programming? Well, obviously, at first there were some people that were more skeptical, and everybody's different with different personalities. We had some people that were more maybe not as extrovert or social, like to think about problems by themselves for a long period of time. People from different backgrounds, different cultures, but in the end, I think when you got more comfortable in it, and we could see the results, people got more comfortable working that way. In the beginning, I think we all felt like we weren't really productive because we didn't really have the keyboard as you usually do, and maybe you don't feel that you're contributing as much. But it's like you have to look at it on the whole picture, like a holistic view of the approach and the problems you're trying to solve, and make sure that everybody contributes and feel that their skills are actually used to solve those particular problems. So that's something that we work with quite a lot in the beginning. But that's definitely something to keep in mind. Please.
How would you integrate a junior developer?
Yeah, so how would you integrate a junior developer is a question. So about our team, most people were quite senior, but we also had more junior people. We had one person coming in directly from the university, joining our team. And it can be quite exhausting in the beginning, but it was like that even for me, who had been working for 10 years in the industry. Coming in there in the beginning, it's a new context, new domain, business rules and terms that I've never heard about. So I think in the beginning, we were basically all on the same page anyway. So what I did to get up to speed with what the team was working on, I was in the mob for the day until like maybe 3 p.m. And then in the afternoon, I spent an hour or so or two to just deep dive into some problems or how to figure out how stuff working under the hoods. And I think it's important in general to have some time, some slack time, in order for you to both build on the knowledge, but also to like sharpen your tools, learn new things, and not always just sitting there full focus on just hammering and drilling and solving problems all the time. So over here.
Have you had big skill differences in your project team, and have you witnessed conflicts appearing about
So the question is about different skill sets and conflicts. Well, we had a quite similar stack of these 15 services that we had. 14 were backend with some external-facing APIs, but also internal-facing APIs. We had just one front-end app. And sure, I'm more of a backend guy, so I had a lot of problems with this React framework in the front end. But when I worked together with the person who were knowledgeable in the front end, we could still help each other out. Like, okay, how are you doing this in the front end? Okay, but in the back end, we use these kind of concepts. Maybe we can apply these to solve this problem, or the other way around. But sure, we had a lot of conflicts in the beginning. Some more heated debates. But I think you have to look at it as like being just constructive. So we had mostly heated debates about code conventions. So like, I'm more for static methods in Java, and some people were really hating it. So we're like, okay, we can't really decide. So let's just pros and cons, put everything up there on the board, discuss the options, and then after a while, you get a common understanding of the problem and the sense of, okay, which do we prefer the best? Let's just go with that, take a decision. There's no prestige or anything like this. But yeah, we're all humans, so it's a lot about psychology. Yeah, in top.
How long did it take for you to get bootstrap, like to get it started and run smoothly?
So how long did it take for us to get this up and running, to run smoothly? I would say maybe a few months. I felt then we had like a good first steps. At least we had a foundation, because in the first weeks we really didn't know what we were doing. But every second week we had a retrospective, tried to improve upon that. We read some blog articles and just tried out different experiments. The good thing with doing retrospects every second week, you can just run an experiment for 2 weeks, see do we like it or not. We don't commit to anything. Some people are very conservative in that sense, like, we've always done it this way, I don't want to try anything new, or we shouldn't change this. But if you convince them to, let's just try it for 2 weeks, that's it. After 2 weeks we can back out. If we don't like it, we can try something else. But we iterating, constantly improving on the processes, quite quickly will become more efficient and more comfortable, I think. In the far up there, yeah.
You call yourself the team lead. What does it mean in such a context, being a team lead?
So what's the team lead in this context? Well, in our sense, it was somebody senior who still had a lot of industry experience, but that person was also more responsible for the well-being of the team members, had one-on-ones and like coaching and making sure that their personal development aligned with the company vision, I guess. It was more at that level, not about like seniority in knowing the code base the best or the domain logic or stuff like that. That was basically everybody was on the same page there. Yeah, another question? Pardon, I didn't get that. So how did we interact with the product owner? The product owner was quite present. He was out there in the daily stand-up meetings. He usually came by the mob and asked how we're doing. I think it's important that the product owner feels that he or she is part of the team. We actually had our product owner sitting in the mob coding with us one time, but after spending 5 minutes in trying to find the curly braces for an if statement, he just gave up. But kudos for trying. So, but sometimes we had the product owner sitting in the mob to just like discuss what problem are we trying to solve, and like are making sure to address all the use cases that the customer will face. So yeah, we have to involve everybody, because that's knowledge that we want to have and make use of when we solve our problems and create new features. Please.
Did you keep your teams together over the run of multiple projects, or was it like a team for one project?
We had teams. The question was if we had the team together for a particular project only, or for span multiple projects. So it was a team that was more, I wouldn't say like a feature team, but more into that sense, like we owned a certain set of external facing APIs and some core functionality for the company. So it was more around that, and regardless of the projects, the company-wide projects, we were together in a team. But we had quite many rotations of people during this time. I was there for 1.5 years, and a lot of people started, and some people left, but they didn't really have such a big impact on the pace or productivity. I think it was more about, okay, now we need to address that we don't really have this particular skill set anymore. So always think about how to assemble the team so we can make sure to cover all these different aspects that we need to consider.
Did you MAR program full-time the whole sprint?
So if we remote programming, if we did that the full sprint, so every day from we had our stand-up at 9:15, so from there on until lunch, and from lunch maybe to 3 p.m. or something. So there was time in the morning for checking emails or try out stuff for reading blogs or whatever, and the same in the afternoon. So we had a flexible work hour, so people can come early or at latest 9:15 then, so a bit varied. So usually we didn't start up the mob until after the daily stand-up meeting, but sometimes we had a morning mob as well.
Is the stand-up then still necessary?
Yeah, that was a good question. So was the stand-up still necessary? We didn't really focus about like the classical things going around. Everybody said, I was doing this yesterday and I'm going to do this today. We rather just looked at the board and like walked the board. Usually, since we're just only working on 1 or 2 things at the same time, we only had like 2 swim lanes on our board. So it's very easy. We just look at what's the state of the current thing we're working on. Have we run into some issues, impediments we need to address? Or do you think we're going to be done when we think we're going to be done? Are the production issues that we need to address? Did something happen last night when we were on call that we need to address? It was more about this kind of things, or like which meetings do we have today that somebody needs to attend, or stuff like that. I think we're out of time now, but if you have any more questions, just feel free to grab me during the conference or ping me on Twitter or LinkedIn or something. Thank you very much.